Hello, folks. Can everyone hear me all right?
Yeah.
All right, awesome. So thank you so much for coming here, and thank you so much for to our organizers, Jason and Vlad, to set this up. It's great talking here. Last time I was on this stage talking about Scala mostly was exactly a year ago. It's pretty coincidental. I found it yesterday when I was Googling my old slides from a year ago. So that's pretty interesting. So it's been a full year. So I've been working at Netflix about a year and a half, work on the same team as Jason. So I'm also working with devices and device metadata and kind of like acting as a gateway to all the devices which run Netflix. But I'm going to talk about the API antipatterns because as we are building APIs, and I've been talking at a lot of conferences, and I keep seeing this need for something like, someone should talk about API best practices. So I kind of took the opportunity, put some slides together, and it came out pretty workable. So I thought, it'd be a great opportunity for you guys to kind of, get an idea of what basics are there for APIs and how REST kind of fits into the whole HTTP model and those kind of things. So we are going to talk about some best practices. We are also going to talk about some anti-patterns, some of them which should be pretty obvious and some of them maybe not. So let's get started. Oh, there you go, malfunction. No, not this, it's here. Sorry about that. All right, awesome. So I'm lobster1234 on Twitter, and that's my personal email. My work email is mpandit@netflix.com, which is my LinkedIn address at netflix.com. And I have a bunch of slides available on my slide deck from my previous presentations. So we're going to talk about APIs. So APIs are essentially a means for software to talk to other software. So, and that's what makes the difference, right? Because it's no longer a human communication. You're talking about machine level communication where things have to be pretty specific. Zeros and ones really matter. So it's not a human conversation where some things are left for interpretation. Now, there is a blurry line, which is where anti-patterns come in, because at the end of the day, it's humans who are writing these two machines, which are talking to each other anyway. So essentially, how do you eliminate that gap? How do you give an impression that it's two machines which have a means, which have some kind of, a handshake and some kind of a possibility where they understand each other pretty well. So there has to be some standard. There has to be some kind of a common terminology for two machines to talk to each other. Now, why are APIs so important? Big reason, you must have been hearing about Internet of Things, and that is something pretty. It sounds pretty buzzwordy, but it's coming true. I mean, you guys saw the Apple keynotes today about the iWatch and the new phone, which is now going to track your fitness and all of that. So Apple is not a fitness company, but they're going to rely on someone else to get fitness data. The fitness company is not a nutrition company. They're going to rely on some other company for nutrition data, right? So all of this kind of comes together, and here you have a device calling some other device, which can call some other device. So this whole ecosystem of things talking to each other, and these are all machines, and this is all possible by APIs. And again, it's human beings who are writing these consumers, it's human beings who are writing these information producers, and it's pretty important for all of these human beings or engineers like ourselves to get on the same page about at least the basic things, so a developer is not frustrated writing software for a fitness API, which works very differently than, let's say, a nutrition API, right? Because as we look at Internet of Things, the developer who is going to consume your APIs is not the guy sitting in the next cube. It could be on the other side of the planet, for all we know, right? So let's do a quick refresher on what HTTP is and what REST APIs are, right? So REST clearly is not a standard. It's an architecture, right? And REST in and of itself uses HTTP. So REST is basically enabling communication over HTTP, right? So if you look at HTTP, that is a standard. but REST is an architecture which is built on a standard. REST itself doesn't have a standard. This is the RFC, right? This is the HTTP standard. If you look at it, it's huge, by the way, and it is RFC 2616. If you want to Google it, I don't know how many of you have read it. Has anyone here read the HTTP RFC? Wow, I'm impressed. This is great. Yeah, so it's kind of good read. So I can see like you guys are into a lot of dry reading in Courier new font. So it is a pretty interesting thing. And I'm not recommending you guys go ahead and read the whole thing. I encourage you to, but it's basically, it tries to cover a lot of use cases which are there for HTTP and where it can be applicable. But for all intents and purposes, we use API for a lot of businessy applications, right? Most of the businessy applications are essentially CRUD. And then there's some business logic associated with CRUD. By the way, when I say CRUD, I don't mean like CRUD, like the gunk which deposits. CRUD is create, read, update, and delete. So we are going to talk about that. But a lot of business APIs, a lot of business processing which happens revolves somewhere around these actions, right? And since REST depends on HTTP, you are dealing with essentially two things. You are dealing with nouns, and nouns are resource or entities. So, and then you have verbs, which are actions on those entities, and of course you have an identifier. So a lot of times when you look at REST online, when you read about REST, a lot of people skip that little piece, which is the identifier. The way I look at it is, if you compare the REST model to a database, or the HTTP model to the database, your table is a resource, which is basically a collection of entities, and every single entity in there is a row. And how do you identify a row in a table? By using an identifier, right? So for every resource should have at least one path to it. Ideally, there should only be one path to a resource, but we all know that's kind of not so practical. There are many ways to reach a resource because these resources are all linked to each other. So you need to have an identifier to identify that particular resource which you are going to act on, and that action is signified by a verb, right? A simple example is basic English, like elementary English, right? You have common nouns and proper nouns. So common nouns, there are your resources, and proper nouns are individual entities within that particular resource. So I can have a resource, I can have a collection of restaurants, and McDonald's happens to be just one of them, and it could be Taco Bell, or it could be, French Laundry or something like that, right? So all of them, this is how you would classify your business entities in a RESTful manner. And then we talked about HTTP. Essentially, we say, what is HTTP? Well, HTTP is a protocol. So what does that mean? So protocol, in general, may or may not be standard, because HTTP is a standard protocol because I showed you that big RFC. But I can create my own custom protocol. Back in the days when RPC, or even before RPC, there was DEC Alpha or something. So they used to have Cobra and all of those distributed computing things. Back in the 90s, a lot of protocols were not standard. They were pretty custom. Like, a client and server, they used to communicate via a custom way, a custom handshake, so to speak, right? It's basically an agreement. As long as the client knows what it needs to send the server and the server knows what it needs to respond to the client with, everything was fine. So a protocol in and of itself is not a standard, but it can be implemented as a standard protocol like we have now. We have HTTP, FTP, and a whole bunch others. So like I said, it all starts with a handshake, and then you have payload, because once you have a handshake, once you communicate between two machines, then you have to send the data or get the data, right? So your payload is defined by two things. It's either a format it's defined by two things. It needs to have a transport and it needs to have a format. So format can be anything. Format, we prefer JSON. It can be XML, it can be plain text, or it can be binary streams for that matter. And transport is the way, the channel using which I can send that data once I have done my handshake, right? So pretty simple thing, right? So let's talk about HTTP. Let's not go into details of how binary protocol transmission works. So if you look at it, these guys were very early REST adopters. So even back then, REST was not even a thing, right? These guys were already using REST. So, and in fact, a lot of idea of using their model to power APIs came from these browsers. So how was the browser using RESTful endpoints? So the way browsers did that is pretty simple, right? They want to get a resource. They want to get static text. They want to get files to download. They want to get images to render using a URL location. And that URL itself is a location to get information from. So as you can notice here, the browser is essentially requesting a resource. I've color-coded this so you can see what the resource is. Server is Netflix.com, and then path is underlined, and then protocol is HTTP. So this is REST in a nutshell. The only thing missing here is the HTTP method, which is GET in this case. And then, of course, when you make a request, every request deserves a response, right? So like Jason talked about the API model, where you always send a request, and there is always a response coming back, which can have headers, which can have the response codes, and it can have some other information about the response. So the first thing which comes out of an HTTP header, HTTP response, is the header, and header describes the response. What this means is that it tells information to the client as to how to interpret the response. Do I need to unzip this response? Or do I need to store a cookie or something like that, which is available in the response, right? It also comes with a status code. Status code, at a very high level, it tells me whether the request was successful or was it a failure, right? And then, of course, I have the body, which contains the actual payload of the response. So if I ask for an image, I'm going to get a base64 encoded image, which my browser or my client can understand and work on it. So you tell the server what to do via actions, right? And actions are essentially HTTP methods, which, like I said, which are pretty much covering a lot of our business interactions, because usually in any business scenario, you are again doing the creates, reads, updates, and deletes, and you have very clean mapping of these CRUD operations on the HTTP protocol. So you can always use post to do create. You can use read, you can use get to do reads, and then you can use patch or put to do updates, and you can do delete for deletes. There are a few more HTTP methods. Generally, when we are building APIs, we don't care for them so much, but generally the low-level client libraries, or for example, browsers, deal with those options, especially when you are, deal with those actions, especially when you're dealing with low-level caching or optimization or protocol switching, like asynchronous calls, all of that, right? So a lot of these things kind of start to emerge like a pattern, right? Because you are solving the same business problems over and over again. So this is an ideal candidate for something like a pattern, right? So, if you go back to the J2EE days, there are Java design patterns, which are essentially simple ways to solve commonly occurring problems. So that's exactly what patterns are in the API world as well. They are reusable solutions to very commonly occurring problems. And common scenarios are, getting data from the server to the server. It could be uploading a file. It could be downloading a file, encrypting a response. All of that is very common scenario, which kind of warrants for a pattern-based solution. Anti-patterns are kind of the same. So if you look at this definition, the first half looks exactly like a pattern, except that they kind of look great on the surface, but in reality, they are not. And they can be traps. They are not going to stop you from doing anything. So you can still have a great API. You can still have performance. But down the road, somewhere, they are going to have problems. And most of these problems occur when we are doing integration, when we are working with a lot more consumers than just our internal developers. And sometimes it starts to make no sense. There is something called code smell. I don't know how many of you know about it, but code smell is something like when you have been doing same thing over and over again, at some point you figure out how to do it the right way, and then when you see it being implemented the wrong way, you get that feeling. That feeling is called code smell. So a lot of anti-patterns, you will notice the ones which I will go through, have certain kind of code smell associated with them, like, yeah, it will work, but it just doesn't make any sense. So So we talked about request, response, and the methods, right? So I'm going to go over the anti-patterns in all of these categories. So request anti-patterns, so overusing query strings. By the way, you can interrupt me anytime you want. If you need, if you want me to pause, if you want me to talk more about certain anti-pattern or best practice. So overusing query strings. Now this is a very, very common anti-pattern which we have seen in a lot of APIs. This is an example of that. So I'm looking for a pet, and the pet's name is Scruffy. So in first case, I'm using a query string. I'm saying name equals Scruffy. And in the second one, I'm doing the right thing, where I'm saying pet slash name slash Scruffy. Now, both of them work. Both of them will give me the same result. But ideally, it's good to have your API in a very structured manner, because the first thing tells me that I can just do whatever I want with it. So I can just say question mark zip code equals something, even though that has nothing to do with the pet, right? In the second case, I have a taxonomy to go after. So this is something which is recommended, obviously, right? And then let's take it a step further, right? In case of the first example, we have name equals Scruffy and zip equals 94568, which means that I'm looking for a pet whose name is Scruffy and who is in this zip code. Versus in the second case, now you can see the difference. The second case is much more kind of closer to what I want it to be, right? Where I'm looking for a pet named Scruffy, and once I have those pets, look for them where location is the name of the attribute of that resource, where zip code is 94568. So this makes a much more sense.
Because it could have been the other way around, like all the pets in that zip code.
Yeah, that's right. You can do that too. So avoid query string for resource identification, right? And you can use them for request metadata. We'll talk about what request metadata is. So query strings have a lot of value, and we'll talk about where that is, except for search, because search becomes like really tricky, because I'm giving a lot of name value pairs to match, and query string makes a lot of sense for those kind of things. Plus I can also bookmark it and do all those kind of things with it. So pagination, filtering, sorting, you want to decorate your request, right? We have all heard about decorator pattern. So we want to decorate your request. What I mean by that is when you go to a fast food drive-through or fast food restaurant, you ask them to, I don't want onions on my burger, or I want extra cheese, right? So you will still get a burger, but you want it done a different way. So every time you try to customize something, you provide request metadata. And the fields here in the red, they are request metadata. So these help me kind of adjust my request a little bit, that give me movies, and then start with 0. And so I'm paginating in this case. Give me 10 of them. Sort these movies by name and give me only name, cast, and release date. I don't want the whole data structure coming back to me. Right? So you can see how query strings make a lot of sense here, right? Because I am bounding, or not bounding, but I'm kind of decorating my request with these attributes, so I get the data which I need without having to mess with the RESTful structure of the URL. Any questions about this? Cool. So use appropriate, actually, this one is, wrong move. So another anti-pattern is, allowing clients to scrape your data via your APIs. So a lot of times, as we work in these kind of business environment, what happens is that you have scenarios where there are bad jobs. I mean, no company can get away from a bad job. So your data will get scraped by a bad job, and one of the ways, if you're exposing your APIs and you want only your APIs to be the single source of entry to your system, you don't want databases syncing. One way to do that is, well, here's my API, and call this API, paginate it, and sync all the data all the time, right? That can be pretty expensive on the resources. Plus, if I have 1 million records, let's say I have a catalog of movies, I don't want some nightly job hitting my API, 100 movies at once, right? Running all night, trying to scrape all those movies. So what is the best way to handle this kind of situation, right? So ideally, request metadata, we can use the same request qualification where we can say, give me a since. So I can say a since parameter where I can say since last 1 day, give me all the records which have changed, or give me a UTC timestamp. And then the caller can persist this since timestamp, and they can call me every night with last night's timestamp. So I know that I don't need to give them the whole data. They don't need to scrape my whole database via my APIs, and I should be able to get just the records which are relevant or which the other party is interested in, because they don't care for records which are not changed, right? So here is another example of where you would address that kind of anti-pattern. So we talked about the request anti-patterns. Let's talk about method anti-patterns, right? So method is essentially making use of HTTP methods in somewhat wrong way. For example, using query strings to overload verbs. Right, this is an example for that. And before RESTful APIs began, this was a pretty common scenario where people used to call these CGI scripts and say, perform this operation, or it used to be called operation equals update. And then it used to say, find this ID of this record and update name equals Scruffy, right? Pretty common scenario. I've seen this, I've written this kind of code, by the way, in the past. So it's pretty common case where people go ahead and they overload the get. So, and all of this is get, by the way. So overload the get with an operation. And it could be unintended consequences, because I can say perform equals delete, and that will work also, right? So that is something which you should avoid, because get should be used only for get. If you want to delete, use delete. If you want to use updates, use patch or use put. If you want to create, use a post, right? Another anti-pattern is using post for all writes. So get for all reads kind of makes sense, but for writing, it makes a difference, because your calls can cause different side effects based on whether you are using post or you are using put, right? So ideally, you would use get to retrieve data or to do searches. And this is pretty interesting, because when you are doing a search, you don't have exactly a resource to go after. So there is no path, technically. What you have is a criteria. So you are working on a criteria. In that case, the criteria becomes your resource. I know it's kind of a little backwards, but having search kind of act as a resource, that doesn't make sense. So ideally, what you are trying to do is, give me this criteria, give me all the resources which match this criteria, and that is the result of my search. So in case of search, you are good with using get. Yeah.
So in your previous example, couldn't you think of a scenario like maybe through a proxy or a firewall?
Which one?
Yeah.
This one?
Where maybe the proxy only allows gets. And maybe somebody did that as a workaround for some specific technical issue.
No, because they only had like a worker.cgi, and the worker.cgi used to take an operation, and it used to take what it needs to do.
That only allowed gets to go through.
Then this would make a lot of sense, but then, yeah, but then again, it kind of doesn't make sense, because you are hacking around, right? Yeah. But I completely agree. That's a good practical solution. So, any other questions, guys? That was a good question, by the way.
How about even the most common thing, like the browsers, you got like this single policy, like single domain policy, right?
Right.
And some people use that get just because they want to avoid, like I want to be able to use my API from other domain.
Yeah.
And then pretty much include the script element with get.
Yeah.
Which is sometimes, like doing something, and then they use like JSON to get like or JavaScript.
Which is the course issue, right?
Yeah.
Yeah. So we have a similar course situation, but then we do a host allow, and we allow those kind of requests, at least from Netflix domain. So when your API is facing the external consumers, it becomes a bigger challenge, but at least your front-ending proxy should be able to take care of that, right? We can talk offline about that. That's a good question, because we ran into this course situation. It's the cross-origin resource, right? Yeah. So going back to this, right, you use post to create or upsert, and then you do a put to update, or better yet, use patch for update. I don't know if patch is finalized yet, but it's pretty close. I know Scala supports it. We have been planning to start using patch for a lot of our updates on our APIs, and use delete for deletes. Anyone know the difference between patch and a put? Yep, there you go. So patch, you can send a partial fragment of the resource which you want to get updated. You can only you can do a partial update using a patch versus when you do a put, you're updating the whole thing with new values. And then of course you use delete for deletions. Another anti-pattern is how do you set a value to null, right? What do you use to set a value to null? Because you can't say that, because if I'm sending a put or a post, how do I specify in my payload that set it to null null, right? Because, for example, if you look at Scala, anything nullable is represented as an option, right? See, finally, I got to talk about Scala in this talk. So anything nullable is represented as an option. And if you set an option to none, there's a very good chance your JSON deserializer and serializer is going to just skip that field, right? So in this case, and a lot of people do very fancy tricks, right? Just send me the JSON and skip that field. If I don't get that field, I'm going to set it to null. Now that's pretty risky because that guy in the next cube knows that that's what you expect. But if someone else is calling your API, how does he know that if he didn't set that field, you are going to set it as null in the database, right? That's a bad precedence. And unfortunately, a lot of people end up doing that. So again, this is the scenario where there is no data, so what do you update? So you use HTTP delete to set the value to null. Now, this is a strange case where the good practice seems like an anti-pattern. Like, why am I deleting something? Because I just want to set a field to null, right? So you have to think about the whole resource. If you remember that path from the browser, right? We were able to go through all the images directory we are going through. Sorry, we were able to get that image going through the headers directory. So think of a collection. Within a collection, you have a resource, right? And a resource has a bunch of attributes. Every single attribute can be operated by these HTTP methods, right? So that's the advantage which we have from an API world and the browser doesn't, because we are modeling business objects or we are modeling real objects which have attributes on them, versus browser only works on limited set of attributes. So browser is going to work on image, it's going to work on text, it's going to work on file, and a bunch of other things. But in our case, when we are designing APIs, we have a much broader spectrum. So we have the object, which is the resource, and then we also have attributes of that resource. So you can, basically, you can include that attribute in your path, and that way you can set it to null. So for example, I can do this. I can say delete pets/ID. So I know I have to identify the resource, give me the pet with this ID, and then caller tag, I want to set it to null. So this is what I'm going to do. Yeah.
If you hit a get on the problem and you want to do a JSON, what's the return value?
You would not allow that. You would only allow gets on the resource.
You allow delete and you not allow get.
Yeah, because this is so I don't have to use post and puts to approach that problem. To answer your question, if I only want to get that field, remember the request decorators we talked about? I can say $fields equals caller tag. So that way I can say, give me this resource. So I can say get pets/ID $fields equals caller tag.
I can use the same pattern for
You can, but generally people don't do that because normally you wouldn't need just one field. You would need at least a few. So practically you would just use a fields kind of parameter, a fields filter, so to speak. But yeah, of course you can do that. You can do gets on individual attributes, even though because when you are implementing this, it kind of becomes a headache, right? What would be the response? What would the response JSON look like in that case if I'm only getting value of a field, right?
Yeah, that's my question.
Exactly. So in that case, I can say like key is the field name, value is the value. But what if my value is another resource?
So another question is, if I want to delete, say, 3 fields in an object,
Yeah.
is a good answer or still in time?
Put would still be, because again, you are setting them as null. So how would the server interpret it, right?
Put is supposed to send an entire object, right?
It is, but then,
If I only some field is supposed to be removed.
yeah, but then like, for example, if we are looking at Scala kind of situation where every nullable field is interpreted as, even I think JSON in Java, if you set a field to null, I think it skips it when it deserializes it as JSON.
It depends. There's an option to. So,
Yeah. Yeah, but I mean, there are always workarounds.
But there's a difference of implementation and
Right,
the syntax. I mean, let's say I want to delete these three fields.
Right.
Delete it
right.
in a more or less of atomic fashion. And if you have three delete requests, it may not guarantee that.
Yeah, that's correct. So in that case, I mean, if you have that kind of use case, I can see having a put work, again, as long as their implementation supports it. Yeah.
It's dependent on resources, the object or the attribute itself.
Yeah, they want to set, he wants to set 3 attributes of that resource now atomically. So it's all or none. In this case, they are not atomic because I have to change them. Yeah.
A question about IDs.
Yeah.
What if we want to get objects, several objects with several IDs?
It depends on your implementation. How I have seen that in the past is where you say question mark ID equals 1, 2, 3, 4, 5, 6, again using the query string. Again, you are using the same filter or search kind of use case to get that. But as far as a resource, a single path goes, if you don't want to use any query strings, I can't think of a way. I know there used to be, or maybe there still is, an API called OpenSocial. How many of you have even heard of OpenSocial? Okay, awesome. So OpenSocial was an open API for social networking. And they supported this kind of thing where I can say, give me friends, question mark, ID equals comma separated list of IDs. So you can go that route. I've seen that happen in OpenSocial where you can say ID equals or ID slash and then comma separated list of IDs. It kind of feels hard to see that kind of URL, but it works. It'll give you back a collection. So if you have that scenario.
I saw that too, but there are all those issues with doing it on GET request line.
Exactly, which is why you'd rather send a bounded search request where your criteria kind of matches those IDs. Or you'd operate on them one by one. But yeah, I mean, if comma separated list works, that works. OpenSocial does it. Yeah. Any other question before we proceed? All good questions. Wow, I'm glad I turned on the lights so you guys are all awake.
This may be a dumb question, but why not use a payload instead of IDs in a URL?
Yeah.
Why not use a payload with IDs in?
Payload in a GET?
Yeah.
No, GET.
No.
Yeah, GET can't have a body. Yeah. Yeah.
What pattern do you use for soft deletes if you have this case?
Sorry, I couldn't answer.
What pattern do you use for soft deletes when you can?
For soft deletes?
What pattern do you use?
That's a good question. The question is, what pattern would you use if you want to have undelete? So, for example, all these HTTP deletes, and that's a very good question because in a lot of companies, you just don't go and delete something in a database. You flag it as inactive, right? And you have to reactivate it. So, that's, any ideas, guys? How would you address this?
You're just updating it with a flag.
Yeah, So in that case, you are updating that active and inactive flag, right?
But you also need an undelete kind of.
So undelete is that you, on that resource, however, it's difficult for you to get a hold of that. So what's going to happen is, like, the use case is this. I have a resource sitting in a database. I do a GET, right? I get that resource. And then I see that it is active. And then I flag it as inactive. So I send a put with that flag off. Or let's say I send a patch and I turn the active flag off. And now it's inactive in the database. When I do a GET with that ID, how is my business case going to work here? So because that object is inactive for all intents and purposes, will my GET even retrieve that? Or will you need some kind of privileged logic there where I'll check that, hey, I got this token, I'm going to check this user's role. If he's an admin, I'm going to show him the inactives. Or you can have resources/inactive endpoint where you can return all the inactive resources or all the inactive instances of that resource, and then you do the same thing. It'll have to be some kind of an admin kind of feature, because if you continue doing successful gets on that ID, you didn't really inactivate anything now.
Maybe you could just return like some weird, one of those weird HTTP codes, like 600 or 700.
Yeah, we'll talk about those weird codes. So, all good questions, guys. That's awesome. Any other questions? Cool. So, always returning HTTP 200. Seen that a little more than I want to. So what that means is that, if you have smart engineers writing your UI code, they will always assume that, hey, if I get a 200, everything is fine. I don't need to worry about anything else till that smart developer sees this, right? So this is really a no-no. And I'm seeing less of this these days, but in the past, I used to see this a lot. Back in the days when I was writing Flickr clients and all of that, I used to run into this the bunch of Flickr scraping APIs, which were basically APIs which were scraping Flickr's APIs, and those APIs were messing things up big time. So it used to be this kind of responses. I used to see these kind of responses also, so instead of a 404. Yeah?
I think there's explanation for that historically.
All right, yeah.
Browsers, Just clients,
Mm-hmm.
they couldn't really handle all of this HTTP responses was non-successful
Yeah.
error codes. So and end up with this all this
Yeah.
artificial solutions.
In fact, that's good. So that is something which I'll talk about when we talk about authentication and cookies. A lot of anti-patterns kind of somehow get introduced because, well, the client cannot handle it. So, and we have done that. Most recently, I think last month, we had to change response of one of our APIs to text HTML because I would not handle application JSON as a response to a file upload. So if I'm uploading multi-part form data, and my API would return an application JSON with a status that, hey, it is successful. Except for IE, everything worked great. But for IE, as soon as it saw application JSON as a response type, it just did not work. So we had to convert it to text HTML. It seems pretty bad, but it worked. And that was the only way we could make it work. Same thing for cookies, right? A lot of APIs, they accept cookies. Why? Because, well, browsers can easily communicate using cookies. So a lot of anti-patterns and patterns, which is why this is kind of like a tricky area, because you have to look at convenience, you have to look at compliance, you have to look at scenarios where all the ports are blocked and the only thing which is permitted on the firewall is a GET, and yet I need to provide all these functionalities. So how do I do that? So what I'm trying to say is that try your best to keep things as consistent as possible. Try to keep things as normal. I can't say standard because there is no standard. There is just convention. So try to follow the convention as much as you can. You'll be happy because you will consume other people's APIs, and if they are written to that standard, you'll be happy. Well, not exactly standard, but convention. You'll be happy. So it's kind of like spreading the love. Any questions before we move on? Error, person JDO not found. But yeah, like you said, it's perfectly valid use case where if the browser can't handle it, the API provider has to return this kind of response, unfortunately. So essentially, this is what you do, and Jason talked about it, is you'll return 2xx for success, 3xx for redirects and caching, so because they are kind of cache control headers and those cache control codes, and then you have 4xx for request or client errors, which means it's your fault when you called me, and 5xx for server errors, which means it's my fault I couldn't handle your request, right? But then there are a lot more API codes. These are probably some of the weird ones which you have noticed. So we have we have, what do you return after a delete, right? You'll return 204, no content. What if there is a failed database constraint, right? I'm trying to update a foreign key, or I'm trying to delete something which I cannot because it has a parent key constraint or any of that, or database constraint, for example, the field is too large kind of thing. So 409 is conflict. So you can return a 409 for that. Method not supported, this is 405. I'm sure as you are developing APIs, you probably run into 405 more than anything else, where when you're testing it, turns out in the code, you had it as get, you're testing it as a put, and then the container says method not allowed, which means that this method, HTTP method, is not allowed on that path. And then let's say it's asking for too much data, so this would be 413. Because I can query. So I've used this in the past where I have the paginated response kind of thing, right? And that's another thing which please implement pagination. I don't have it in my slides, but if you are working on an API which returns resources, please, and have default values on them. So when Jason was showing you Swagger, we have values in there. I don't think his example had those because he wrote it custom for the meetup. But we have a start and a count. It starts default to 0, count defaults to 20, because we don't want our servers to choke. Because someone could easily say count equals 1,000,000 and start equals -1,000,000. And now you are having to query all of this data, hitting your caches, hitting your databases. So always have very practical limits to all the data which you can serve. So a good idea would be to always have pagination. That's, I guess, not exactly an anti-pattern or a pattern, but a best practice is to implement pagination and have limits. So for example, if my limit is 20, or my limit is, let's say, 100, and you ask me for 1,000,000 records, so I can say question mark count equals 1,000,000, I'd return 413, saying that, hey, you're asking for too much data. And if you notice, 413, it starts with a 4, it's a client-side error. You don't have to process that request, you're gonna reject it at the gate. And then this is the latest one which we introduced in our APIs, is 418. It's, who knows what 418 stands for? I'm a teapot. And 418 and that's really it. I mean, it's not like a joke or a meme. That's what it stands for. So we started returning it for validation failures. So for example, to give you, all the devices which you have which run Netflix have an ESN, electronic serial number, which has to comply to a certain regular expression. If it doesn't match, what do we say? So that's where we started using this, where if you give me a request which fails validation, first class validation, you return a 418, so the UI knows that the request has had a validation failure. Along with 418, the response body, again, all of these, you should include response bodies with them to describe what happened, especially if you have error response codes. Like 204, that's fine, that's what it means, 204, no content. But failed database constraint, add some information in the response body saying what happened. So we use a JSON where it says messages. So the structure of the JSON, let me talk a little more Scala here. It is basically a tuple where I have the key as the string messages and the value is a collection of strings. So messages, arrow, collection of strings. So all my validation errors, I can see them. So please return bodies so your consumer knows what exactly happened. Always returning a 401 for auth failures. So 401 makes sense, that's what it's for, so when authentication fails. But then we kind of start using the same thing for forbidden, right? For cases where there is a 403, 403 is forbidden, 401 is unauthorized. So when you have kind of locked down resources, you have to differentiate between someone who can't even get in the door versus someone who can get into few doors but not all doors, right? So authentication versus authorization or entitlement, you have to differentiate them for the client, because a lot of times the client will authenticate and then the client will try to access a resource and you will keep throwing a 401, and on the other hand, the client is like, well, I just logged in, I have this cookie which I'm sending as a token, So I know that this works. I hit your login endpoint and I got a successful response. So this token is valid. But then why do I keep getting 401 when I try to access this resource, right? So use 401 to indicate that the client needs to authenticate. Generally, if you want to really follow that RFC, it says that your response headers should tell them what authentication method to use to re-authenticate, right? So, but you don't want to go into that much detail, but at least tell them that it's a 401 and not a 403. And use a 403 forbidden to indicate that the credentials do not allow access to the requested resource, right? So the way I look at it is, 401 is come back with a key, and 403 is your key doesn't work with this lock. Any questions about 401s and 403s? Cool. We have more lights I can turn on in the back. Yeah. I only turned on 1 out of 4 banks. So, yeah.
Is 401 appropriate code for authentication your bad credential or anything else? If I try to authenticate, what should
You would return a 401 if you have bad credentials or you have no credentials. Yeah.
In case when you're trying to access a resource and you're not allowed to access it, you return 404s, not to expose that this resource actually exists?
That's a very good question. So I don't know if all of you heard that question, right? So that's a good question. So I have a protected resource, right? And I want to limit access to it. Now, if someone tries to access that resource, I can either tell them forbidden or I can tell them 404, which means that resource is not found, which is pretty good scenario here, right? Did everyone understand the question? So yeah, so I can return a 403 and tell them that you are forbidden from accessing this resource. What that means is that, hey, I have this resource somewhere, I just won't give you the access, I won't give you access, so you can come back and hack me again and use a token which may work sometime, right? Versus returning a 404, which means that the token which the resource which you are asking for doesn't exist, while internally what happens is that they don't have access to it. Right.
Or you could do it intelligently, if you're a Netflix employee,
yeah,
you get 403, and if you're a public, you get 404.
Wow. I'm not sure if you're seeing my code from there, but that's exactly what we have done. So in our case, so we work with partners, right? Like Jason said, so if a Samsung guy comes in and he tries to access, well, this has never happened, by the way, but our APIs, right? So we have tests where we have a test user, Samsung, trying to get firmware properties of a Roku hardware, of a Roku device, right? In this case, how do you do that, right? So in that case, the Samsung user who is asking for this Roku information gets a 404, versus if you are an admin, you get a 403. So yeah, we kind of take care of that in that way. A little bit hackish, but yeah, to answer your question, I think if depending on how critical of a situation you are in, if it's too much programming overhead, I'd say keep the distinction clear. It's okay, Apache does it all the time. Apache gives you forbidden when you try to access a folder which you don't have access to. So it's not a really bad idea to, continue returning a 403 versus a 404. If you really have sensitive security, if you really have very sensitive resources, it's perfectly fine, because this is kind of one of those patterns, right? Where if you authenticate 5 times in a row within first 25 seconds, I won't even accept your authentication request for another 10 minutes, right? You're kind of locking them out, right? So in this case, you are kind of protecting that DDoS kind of a flooding behavior where you keep spinning the wheel till you get like a 403 instead of a 404, right? Cool. Another anti-pattern or another use case which normally gets solved with an anti-pattern is processing requests synchronously, even time-sensitive ones. So I'll give you an example of one case which we ran into where we have an API endpoint which accepts a file. That file has 100,000 device IDs. And we had to process all those 100,000 device IDs, go update the database, fire off some tasks, and come back to the customer, to the caller, to the requester, with an update of how many records succeeded out of that 100,000, right? All of this doesn't make sense to have client wait for 5 minutes for the this, Again, we are not talking about browsers, we are talking about machines. You can go and you can configure your timeout to anything you want. I would rather not tell my partner to say that, hey, go ahead and change your configuration so your client waits for 10 minutes, right? Doesn't make sense. So use asynchronous operation in that case, right? Return HTTP 202, which means that your request has been accepted and we'll let you know. It's kind of like a non-committal response, right?
You like return a task ID or something?
Yeah, exactly. I just want to make sure like there's, So you should always help. Like I said, every request deserves a response, and that response should help the caller in any which way, right? So in this case, what you'll do is I'll start the process, and that process will probably have a task ID, and then I can have a bunch of endpoints where the requester can query, given that task ID, give me how many records were processed, or give me what percent remains, or how long is it going to be, right? So you return a status URL with this, or like you said, you can return just a GUID or a task ID, and then they can use that task ID to go and find other endpoints. Now, how would they know which endpoint to call once they have a task ID? That's another anti-pattern we'll talk about in a little bit.
Anti-pattern is sort of a way to trick HTTP to become a notification mechanism.
Exactly.
So you can kind of hack it into many ways.
Yeah. In fact, 202 is becoming kind of more and more popular because if you look at continuations, a lot of that kind of relies on 202, where it's like asynchronous processing on this thread with a callback, so you can continue processing other threads while this guy is waiting. So the last category we talk about is organizational anti-patterns. Now we talked about request anti-patterns, response anti-patterns, and method anti-patterns, touching different areas of HTTP. Now organizational is not so much HTTP, but the way you have modeled your resources, right? So one anti-pattern would be not differentiating between entities and instances. If you go back a while ago, I talked about the database model where you have the table, which is the resource, and then you have rows in it, which are different entities, right? So, for example, this case, pets, type equals dog and name equals big. What do you think it's going to give me? It's going to give me all the pets, which are dogs, who have the name Big, right? We have a puppy here at Netflix. His name is Big, so I'm going to give him a little shout out here. Versus if you look at the second URL, I have pets, which is a collection. Within pets, dogs, which is another collection. And within the dogs, give me a dog whose name is Big, right? Which one of these two URLs kind of looks much more cleaner, looks much more like restful, so to speak? Again, both of them will work, no doubt. Yeah. I mean, based on your implementation. If your implementation can handle both will work. So the first one is, again, I'm kind of leaving it open. So if I say type equals foo and name equals big, what should I get? Should I get a 400 or should I get a 404? Because obviously I'm not going to find a pet with type foo. Versus in the second case, where I get a 404. Right? Second case, I won't even have that valid path in my server. Versus in the first case, I have to accept all kinds of paths, and then I have to run a validation where I'm only going to accept dogs and cats and maybe snakes, right? And then I'm going to decline everything else, right? So you are having your HTTP container do a lot of heavy lifting in this case, right? Cool. Any questions on this one?
Your will be too deeply nested?
It will be deeply nested. So a lot of things, the more perfect or the more deep nested you want your APIs to be, which is where I think you asked me about that question, right? How do you work on individual attributes? You can go deeper and deeper and deeper, right? So the more deep you go, it's great for discoverability. It's great for, having your API kind of self-documenting. But at the same time, you have to deal with the situation where these APIs can get way out of control, which is where you kind of use that query string to help it out. So I can say question mark fields equals a.b.c, where now I'm even getting a child attribute of a child, without getting the parent of the parent of the parent, right?
So I
Yeah.
would say it's different semantics there. The first one is kind of cover the filter, and we should become 200 and make the empty array.
Yes.
And the second one, you can get more.
You can get a 404, exactly. So the first one, again, we are opening it to interpretation. And you had a very good interpretation where first one, it's valid because /pets, perfectly valid. Type, perfectly valid parameter. Name is a perfectly valid parameter. If I don't get anything, should I return a 400 because foo is not a valid type? Should I return a 404 because I couldn't find anything? Or should I return a 200 because you gave me everything valid, nothing matched, right? So now again, you are leaving it to interpretation, which is the kind of the mother of anti-patterns is assumptions, right? So instead of having a clean path, now we have these forks to look at, right?
Quick question.
Yeah.
Can you go back to the last slide? So on the second one, right?
Mhm.
Let's say it becomes, the payload is pretty big,
Yeah.
and you talk about adding default values like count and start, right?
Yeah.
So that kind of like gives you the path edition.
Yes, that's right.
If that's the case, the first one would be better, or the second one?
You can pass those parameters on the second URL also because they are kind of request decorators, right? They are request metadata. You are giving more information about the request. You are not giving information about the resource. Yeah.
When you put those lines more on the search, don't you think so? I'm just,
It will get longer, yeah. I agree with that, yeah. So think of those flags in the query string as request decorators, or they are request kind of tuning parameters. They have nothing to do with the resource. You can use those exact parameters with other resources too. Yeah.
You talked about the deep nestability of things.
Yeah.
The object as you go to attributes, right?
Uh-huh.
The question is, again, you brought this earlier, but I just wanted to.
Sure.
Would you do, suppose you want to null a particular attribute, instead you do a delete going down all the way to that.
Right.
How about a put with specifically the meta portion saying what attributes you want to really null?
Yeah.
Would that work?
That will work too. Again, like the put implementation, I mean, the put example would kind of tie it to the implementation because my implementation has to know that I support this ... kind of things, right? But of course, if I document it, if I document this use case, it will absolutely work, right? Yeah.
So, how does one deal with pagination response, which you suggested, versus frequently changing resource? So you give, like someone wants a whole.
Then you would use a since parameter, where just like Twitter Firehose, right? You give it a since ID, and it's going to keep giving you, it's going to keep a live connection, and it's going to keep streaming all the tweets which are changing in that case. Or I mean, you would have to rely on the whole asynchronous WebSocket kind of model in that case, because it's not exactly you're asking for a RESTful resource. In that case, you're asking for a stream which you're going to keep pulling from, right? So, but yeah, the way Twitter handles it is that they have that question mark since. I think is it since or ID or something like that, yeah, or nonce maybe. So one of those parameters which keep streaming any new tweets which match their search criteria, for example. But yeah, it's a pretty valid use case, especially for news or streaming quotes, something like that, yeah. Yeah.
How do you, in a way, world that there's no something else? Obviously, your business logic is not just creation, deletion.
Yeah.
So, how do you recommend to say, send a signal for object to do something?
So the question is, what if I have use cases which go beyond the CRUD interface, right? Let's say I want to rent a book, for example, right? Because renting a book is my resource, library is my collection, and the book title or book ID is my identifier. How do I rent this book?
You post a command.
Exactly. So in that case, you are changing an attribute of that book, because instead of keeping it open, right? Because the status of that book will say it's on the shelf, right? So instead of updating the status to on the shelf, I'm going to say rented, and then it'll have an attribute called who rented it, and when it is due, it's an update, essentially. So a lot of business cases, if you look at them, they can all be modeled around CRUD. Very rarely you will run into a case which you really can't model into this. Guys, how are we doing with time? I appreciate all the interactive session, but at the same time to make sure you guys are cool with it, right?
We're good to midnight.
Awesome, all right, yeah. The doors are locked, so we are screwed anyway, so we are good. So, so namespace your resources in a collection, use paths and identifiers to traverse. So what I mean by that is, pretty much to what you talked about, where it gets really long. Yeah, it does get long, but it is also self-descriptive, and it's really helpful if you go that way. Again, this is not a law, this is not a standard, this is just one of the best practices. It may work, it may not work. If you have really deep nested objects, I would never recommend this. So, but namespace your resources wisely, because that's how the developers are going to look at your resources. And use paths and identifiers to traverse this graph, right? So you can use IDs and paths. So IDs and paths essentially are the same thing. ID happens to be a primary identifier for the resource, which is normally a number, which is guaranteed to be uniquely tied to that resource. And then path is another way to get to that resource, which can result in multiple resources. So I can say like pet/dog/ cruise, and there could be like 5 or 6 dogs which are cruise, versus if I say pet/123 or pet/dog/123, I'll only get one dog whose ID is 123. So using ID in the resource identification path, again, I put question mark there and not a warning sign, because this is not exactly an anti-pattern, but this is just something which kind of feels hard. A lot of API providers, they just assume that if you don't qualify your path with an attribute, so for example, if I don't say pet/dog/name/scruffy, and if I just say pet/dog/123, it's a dog with ID 123. I don't have to say pet/dog/ID/123. So ID is kind of implied. So this is what the example is. So pet/ID/1234 versus pets/1234. Makes perfect sense to skip ID in that case. Let's go with the convention that if I don't pass anything, it has to be an ID. It can't be anything else, right? So use all other attributes in the path except the ID. ID is kind of implied. This is like one thing which can save you 2 characters on that long path, right? So resources in an island. So this is pretty common scenario which happens, right? Because like Jason showed that example of the street lamp, right? Where there was a % of APIs which people could see and all other APIs which were in the dark. So that happens a lot. So it's like kind of resources in an island. So I look at one resource and then that resource has many connections, right? Because every resource is tied to others. In fact, I can talk about our movie hierarchy here, or device hierarchy, for example. A device has a manufacturer. A manufacturer has a contractor. A contractor has a bunch of chipsets. Every chipset has a chipset manufacturer, right? So you can go deep and deep, and every resource is tied to each other. So how do you return all of this? Do you return the whole database at once? Or do you only return the IDs, right? And you are stuck getting all these connections. So normally people are like, well, I'll just return an ID. So if I'm looking at a device and the device has a manufacturer, I'll just say manufacturer ID 1234. Now, how does that help your consumer? Because now he's stuck with the ID. He doesn't know how to call manufacturer. Is it all uppercase M manufacturer or lowercase manufacturer? Is it V1 or V2, right? So use Hatios or something similar. Now this is like a pretty heavy name. If you Google it, you won't see a whole lot of results. It has like half a page Wikipedia. So don't expect internet to help you with this. So this is essentially, it's like a guideline to tell you that instead of returning IDs, return simple. I'll explain it. I'll kind of distill it down for you. So you just return, instead of returning an ID, return the ID-driven path for that resource. So manufacturer, I have an API to get manufacturers by an ID. Just return that path and call it like a link. So you follow the HTTP pattern where you have a link, you have an href, and you have a rel, right? So you can say rel is manufacturer, href is that location of this particular resource. So use something like that. Use resource description, use links to help your client traverse through this object web instead of just giving them an ID or worse yet, giving them nothing. So another anti-pattern is read code to figure out resources and attributes, right? This is the same thing. Again, kind of an issue with discoverability and self-definability, or what's the right word I'm looking for here? Self-documentation of the APIs, right? That doesn't exist. I don't know how many resources I can use on this API. I don't know how many operations I can use on those resources, and I don't know how those resources are connected to each other. So use meta pages for resource description. Now this works at the resource level. So for every resource, like, I have an API to get a manufacturer. How do I know that what fields I'm going to get in that manufacturer? Do I need to actually get a manufacturer and then reverse engineer what this looks like? What if the ID which I call the manufacturer with doesn't have a bunch of fields, but maybe other manufacturer will have those fields, right? Where is the description, right? This is that XML kind of DTD kind of thing, but we are not going to make it that bad. So what you have is you have a resource meta or collection meta. This meta endpoint will give me a JSON description of that object. Kind of like it'll say that this is the attribute name, this is the type, these are the valid values, or this is an enumeration, right? You are describing that resource. So it's a meta resource. So give a meta endpoint. This is going to be really helpful for your developers. APIs are not discoverable. Again, consider something like Swagger or IODocs. We use Swagger quite a bit. Jason talked about it. And then relying on cookies for authentication. Again, the same thing, which means that I'm assuming that my client is always going to be a browser. And if you want to use cookies through real Java application or Scala application code, it can get a little painful. For browser, it's easy because browser is doing all the hard work. When you're writing code to handle cookies, you are doing all the hard work, right? So don't assume that your client will always be a browser. So cookies are great, but well, accept them as a fallback. If you don't have a query parameter or an HTTP request header as an authentication token, see if that value came to you via a cookie, but don't use cookies as your primary and only authentication resource. Another one, and guys, we are kind of nearing towards the end of this, so yeah, just to wrap up a few state level anti-patterns. So storing state on server nodes. So there is a difference, and state is pretty, I'm sure there will be a lot of questions around this. So state is a pretty kind of controversial thing. One model is share nothing, where you share nothing between nodes, right? Another is where a cluster can share information between nodes, but there should be no information shared between clusters, right? So there are many models. Ideally, I like to keep things super simple, right? Just keep things stateless. Don't store any transitional state, because if you look at state is basically what a resource looks like. So we talked about tables, we talked about rows, let's talk about columns. Those things in those columns, that's what a state is, right? So requests can either modify state of a resource or read it. They can only do two things, right? By the way, deletion is modification of the state. So you can only do two things with that state. And then all requests on the cluster see the same state of the resource. And this is very important. This will drive your caching. This will drive a lot of things. You don't want your load balancer to route me to a node which gives me a different state versus another node which gives me another state. Now, going back to this slide, right? This is what will cause that to happen. So one node will have one state. For example, using hash maps in Java to store some things which we think will never change, and somehow they do. So now I have one JVM or one Java process with a hash map with that cached value which has changed. The other node happened to somehow pull that fresh value from the database, and now every time I hit F5, I see different results, right? So don't store state locally between the server nodes, and you'll be really happy. And debugging these kind of things was a pain. I've kind of ran into this situation in the past. I don't say that I have written code like that, but every time you have a cluster, you'll have some kind of hash map caching going on there, and you will return into that. So maintain a state in a database, and if you need to if you need to store transient state, use a database. Use something which is common to all the nodes in your cluster, and not clusters. Stay away from hash maps as far as caching data goes. So if you are doing any node level caching, if you are caching any configuration parameters which can change, you will end up with a situation where all nodes have different values because someone went and changed it in the database.
What about caching in the load balancer?
Caching in the load balancer or caching in memcached? Oh, wow.
Load balancer, or yeah.
Yeah, you can, memcached is a shared pool. So you can use memcached, you can use the database, use something which is shared across all the nodes and not something which is only visible to one node. So versioning, I think you asked a question about versioning, or someone did. Yeah. So versioning, use 301s to redirect and retire APIs. Don't use 302s in this case. 301 is kind of like a permanent redirect, which means that if you're asking me on this URL, I'll redirect you to V2 or V3, right? So versioning, you use 301s. And then for caching, there are a lot of HTTP headers. In fact, if you go read that RFC, if this talk has inspired you into reading that text, please do that, and you will notice a lot of details on caching. In fact, caching was the most interesting piece I saw in that RFC, where they talk about caching at great lengths, and caching is a lot. I mean, expires before or expired since. It has a lot of headers. It has a lot of details in there. And then caching response bodies, you have to be careful about that because a lot of people cache post response bodies, which is not how post is supposed to work. So generally you will easily cache something like a get, but post you should not cache, and I think even the tools won't let you cache that. So if you are using something like Varnish to front end your APIs, make sure that Varnish is not caching your posts, and it only caches your gets. All right, that's pretty much it. I leave you with this awesome cartoon. We talked about nouns and verbs and actions. This is pretty relevant. Any questions? Yeah. Oh, sorry.
I have a question.
Mm-hmm.
Since you have such a complex enterprise,
Mm-hmm.
machine talking to machine schema,
Yeah.
why don't you use web services? Designed for
Web servers?
communication between processes rather than web server between the web
I think he means like SOAP or something like that.
So web services.
Oh, these are RESTful web services which we have built. Yeah, they are.
I mean,
Yeah.
all that stuff. Web services.
Yeah, they are web services, except that they are RESTful web services which use JSON as the.
Yeah, but that's not a standard, right?
It is not a standard, I agree.
Yeah, but WSDL web services, just SOAP.
Oh, okay, so that's what you mean, right? Why don't we go with something like a WSDL and have SOAP endpoints? So technically, yes, that would work. Practically, I think convincing someone to write WSDL in 20, yeah, it is, yeah, exactly. But then just for documentation, I think it's a bigger price to pay just so I can get exactly, yeah.
If you create such complex APIs,
yeah.
then maybe.
No, so that's why. So we do a lot of microservices based development. So even though these APIs look a little scary, but if you look at the code, it's really simple. If you look at how they are deployed, that's really simple. So it's not that there is one Uber service which is doing everything. In fact, we have 53 endpoints, all doing different things, and they all do bits and chunks of things, and we kind of orchestrate them. So we achieve big results using these small little services and coordinating the service, coordinating the call sequence between them. So completely understand your point. Yes, if it was like a banking application, it makes perfect sense because then I have to look at transaction. I have to look at SAML, right? Those kind of things. We don't have those constraints. Yes, the business process is complicated, but we are able to manage it through kind of microservice level deployment and development. So it works out. And Swagger is a little bit of an extra effort to get the APIs documented, but we are able to have our UI guys start developing against our APIs without us writing a whole lot of functional code. We just write stubs to power Swagger. Swagger also acts as a test harness or a test sandbox where they can send requests through Swagger. It has that API console, and then our API can return canned responses. So now UI is not blocked for us, waiting for us to implement the whole services. They can develop in parallel. Kind of like interface first approach. So does it answer your question?
So basically, your APIs are not that complex to run.
They are complex, but we solve that complexity by chaining a lot of simple APIs. So yeah, we kind of abstract all that complexity, and we just have very small discrete services, and they are all stateless. So for us, it's just a matter of sequencing them correctly. Yeah.
One last question I have regarding deep nesting of the
Mm-hmm.
tags, right? I've seen other, like OpenStack, for example.
Yeah.
They do this notion of, on the creation of a resource,
Yeah.
they assign an ID actually, they create it actually, which doesn't change throughout the entire lifecycle of the object itself.
So HTTP 201, you get an ID back, right?
But then what they do is they also give a path which is relatively very simple. So you can say, ports, we go all the way to
Exactly. So like I said, your response should always help the client. So ideally with a 201, I should expect to get a URL, especially since it's a synchronous creation, which means that I sent a request, and if you're giving me 201, which means that you have already created that device, you are not creating it in the background. Otherwise, you would have given me a 202. So if you are giving me a 201, give me a path to that resource. That's perfectly valid. In fact, a lot of our APIs do that. So yeah, so you get a 201 with the URL. With a 202, you get the status URL. Yeah. Any other questions, guys? Yeah.
So you talked about a lot of things. You in initial first slide that the other guy was presenting, he had shown that
Jason, yeah.
Jason. He had shown SSO and the REST service. So do you use that in your system for authentication?
SSO, and what was the other thing?
So you have the REST service and you have an SSO server.
We have an SSO server.
Right. So in that case,
the
authentication would happen at the SSO layer. So if there is a client, the client will go to the SSO, get authenticated, and then all the requests will come to your server.
Right.
So how does that work?
So did everyone get that question? It's like, how do we pull in the SSO authentication into this architecture? So the reason why we don't have our client go and authenticate directly with the SSO layer and then come back to us is because if you remember, he had another block there called legacy. So we kind of hide that complexity where we authenticate with SSO. We also go and authenticate with the legacy and give them a token which can log them into both of them. So we have an SSO, right, which everyone else uses. Then we have a legacy which has its own authentication, which we have to call because, of course, it's legacy, right? We have to get data from there. And how do we authenticate with the legacy? So we do all this for the user, give them a token which works on both of these systems, which will work on other systems because it's SSO. And then it will work on legacy because we have kind of tagged along that legacy token on the SSO token. So we authenticate on both systems, and that token is valid on both.
Okay, but for the SSO authentication, you have to be on that particular site or server.
It's an internal server. We use Atlassian Crowd as our SSO provider.
Okay, that's internal.
It is internal, yeah.
In this case, suppose if you had something external like...
But we have partners calling our APIs. In that case, we give them the token which we get from the SSO for them. So they can use that token to us as a query string parameter.
Something like OAuth?
No, we are not. So, I mean, for consumer APIs, OAuth definitely makes sense. But for us, our clients are partners. So we just use a token with a shorter expiry date.
But it results in multiple calls, right? Because you're proxying on behalf of that, right?
That's right. Yeah. Oh, we cache those tokens internally. Yeah, we use Cassandra as a cache store for these tokens.
For that question where I was talking earlier about doing asynchronous notification, I think they call it comment or something like that.
Yeah, Bayux,
Would you
B-A-Y-U-E-X.
consider that an anti-pattern? What do you think is the best practice for doing that type of thing?
So you asked a similar question, right, about streaming data, right? So I would use WebSockets in that case, because WebSockets is a standard which now I don't know if it is on all browsers already, or is there some browser?
HTML5 now?
Yeah, that's WebSockets. Yeah.
Okay.
So I'd use WebSockets on that. And on the back end, yeah, there are plenty of streaming frameworks now on the back end. Yeah. There is starts with an A, actually. Scalatra started building that. Atmosphere, yeah. So Scalatra guys are working on that. So there are plenty of frameworks on the back end. On the front end side of things, of course, WebSocket support is there on a lot of browsers which you actually want to work with. So, yeah. Cool. Any other questions, guys? All right. Thank you so much for coming, guys. It was awesome. Thank you.
It was very interactive, right?
Yeah. There is kind of a pure HTTP pattern for that, which is if you serve a page, you serve a resource that just has like a list of your JSON resources. Then you don't have
JSON
you can tag that as a cacheable.
Okay. All right. Nice seeing you.
Pull that page.